So maximum and minimum values it's going to be the highest. It is the highest point on a graph. It's actually the y value for the highest point on the graph. So if I gave you something like this, what would the maximum value be on something like this? Infinity. Good. The maximum equals infinity. Okay. The minimum value then, yeah. That's the lowest, the y value for the lowest point. Yep, in this case that would be right there at 0. So maximum and minimum are part of the range. They're calculated by the range. Let's take a look at this graph real quick though before I give you the next idea, and it's pretty short. Our notes are pretty short today. If I'm looking at this graph and I'm wanting to look at whether it's increasing or decreasing, am I increasing or decreasing as I'm coming along here? Decreasing. Good. Does it change?
Yes. Decreasing.
So here it's decreasing, right? And over here it's increasing. Does everybody agree? Okay. So looking from left to right, we've got a decrease. It changes, and then we have an increase. Anybody remember from the other day, at an individual point, can an individual point be increasing or decreasing?
No.
No, right. Individual points are not increasing or decreasing. So this lowest point is neither increasing or decreasing. It's actually kind of in no man's land there. It's sort of where the whole thing changes. But if I identify any point on this graph, at that point it's neither increasing or decreasing. Technically. We'll see some stuff here in just a minute that might make us a little bit confused about that. So how do we note increase or decrease? To answer this question, we use domain. Increase and decrease always uses domain. And domain are the what kind of values? X. Good. So since we can't, since no point, no individual point is increasing or decreasing all by itself, we can't use brackets. There's no inclusion on this. So no brackets are used. We can use them for domain, but we can't use them for if it's increasing or decreasing along the domain. All right. So going back to my picture here, I know I'm kind of cramming here in the screen for what you can see, but as I'm coming across, as the storm front is coming across, am I touching the function here somewhere? Jackie's right. Yes. Because this continues to go up and up and up and over. Somewhere up here, these are going to be touching, right? And so if as far back as I want to move on this x-axis, somewhere I'm going to be touching that function. So this is decreasing from where to where? That would be correct. Negative infinity to 0. So this is decrease. This particular, we'll do this particular one. We'll just use dec. Decrease for x is an element of negative infinity to 0. At 0 it changes, right? And it increases. How far does it increase? Forever, infinity. Yeah, yeah. So increases. X is an element of 0 to infinity. That would be this guy up here. Kind of tricky. I want to look at a problem that's on our task. If you turn to the first page of 3.3, it's the task. You'll have this guy here. One of the other Math 1 teachers and I were talking yesterday, Mrs. Simpson. We were talking about exactly this problem. This particular situation is a problem. Is it increasing or decreasing? It's pretty obviously decreasing, right? But is it, oh gosh, now I got too many words running through my mind. What's the word for individual dots? Continuous or discrete? Is this one continuous or discrete? Discrete, because we don't have the dots connected, right? So there's no connection, so it's discrete. But it seems obvious that it's decreasing. But earlier I said, and in fact in our notes the other day I said that we can't be decreasing at an individual point. So is it decreasing here? No. Is it decreasing here? No. Here? No. No. So how can we say it's decreasing if it's discrete? That's a bit of a problem. Do you guys see the issue with that? And yet it's pretty obviously decreasing. Here's the other thing. If I did the range on this, let's define the domain and range. So on this case, x is an element. We've got individual points, and it looks like 1, 2, oh, hang on a second. That would be half. Looks like 1, and then 2, and then 3, and then 4. everybody okay with those values for the domain? So that's looking at the x value here, 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 and here, right? And the range then is going to be whatever that is. We'll have to do some guessing, I think. Here, 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 and here. So the range, y is an element of the set. What do you say? 1/4 maybe, 0.25? Okay. Or 1/4. Looks like this is a half or 0.5. I'm going to go to fraction. You can put 0.5 if you want. And then 1. And then 2. And 3. So there's our domain and our range. And when we write domain and range, we always go from the smallest to the largest. Is it at all possible to see, if I gave you just this without the graph, would there be any way that you could see or say that that is decreasing? I think the answer to that's no. I think the only way we can see that this is a decreasing graph is for us to see that the general trend here in the points is that it's going down. So this is a real problem. And how we're going to note this kind of thing is actually something I'm going to talk with our other math teachers today about at lunch. So I don't really know the best way to note this, except this is what I would write right here. If I were a student and I was possessed with this problem, or posed with this problem, this is what I would write. That it's decreasing at this, for this domain. That's exactly how I would answer that. That may change. If we end up doing it differently, I'll let you know next time. Let's look at a couple of other problems. Let's look at number 1. Let's start with simple. Is there a maximum and a minimum? Yeah. Let's see. Is the function increasing or decreasing? It's doing both, right? So we have to say where it's doing both. And the domain and the range and end behavior, I don't really know what that means. I think that turns up. I'm going to get rid of that. End behavior. Okay. So let's write the domain. It's kind of tight, but let's see if we can get the domain in here. X is an element. This is where I'm dragging the storm front across. When do I start touching the players? -3. Included or not, do you think? Included. I think it looks like a solid dot. And as I'm dragging this across, I'm just looking at the x values. When do I quit touching the players? Yeah, about 4, huh? That looks like that's included as well. So let's look at the range. So as I'm coming up, as the storm front's coming up from the bottom, when does it start touching the players?
0.
Yep, and when does it quit touching?
4.
Yeah, 0 to 4. Okay. There must be a lot of players. They're all standing in a line. I would think that would be a bad strategy if I was playing Fortnite, right? Standing next to the people that are trying to kill you in a line. All right, probably not so good. How about a maximum and a minimum? How about if we write maximum instead of as just the y value? How about if we put it as a point? What would the point value be for the maximum? 1,4, right, good. The max is at 1,4.
4, 0.
The min You say that's at 4, 0. I agree with that. Okay. This actually we would call a relative min, but we don't need to worry about that right now. Later classes you'll worry about that. So where is it increasing?
Beginning.
The beginning? I don't know what the beginning is. Starts increasing at
31.
oh, wait a minute. I can't conclude. Right? I'm starting to put the bracket in. I can't do that. That'd be a mistake. Bad teacher. -3. When does it quit increasing? At 1. Yeah, at 1. The x value is 1. And then it decreases. X is an element of 1, 2, 4. There we go. This, it does ask for it. This is a relative minimum. It's not the absolute minimum. It's not the lowest that the values go, but it's lowest within its sort of area of the graph. All right, let's look at number 2. I want to talk about number 2 here. It seems like a very long time ago that we talked about
Stop me this time.
wake up. It seems like a very long time ago that we talked about functions. And I think I showed you how to decide if a graph was a function. You guys remember the vertical line test?
Yes.
So if I could draw a vertical line anywhere and touch in 2 places, it's not a function. So is this a function or not? It's not a function. If it's not a function, it causes us some problems. We can get the domain and the range, but the maximums and the minimums and increasing, I think the real problem here is, what's it doing? Is it increasing or decreasing? It's doing both, right? So it's a problem. So if we have something that's not a function, there are some things we could say about it, but let's just do this. Let's just go not a function. Not a function. So we're going to skip it if it's not a function. I wonder if there are any others that are not functions. Number 3, is that a function? Yes, I agree. That would pass the vertical line test. 4 was a function. How about 5? Yeah, that's not a function because here I've got a problem. Is there any other spot? Yeah, it does. It looks like at 5, but it doesn't matter. Once you see that, so this is not a function.
And then 7.
I don't know. Okay. 7. Let's do the vertical line test. Am I touching more than one place at any time? But I'm not, because it's an open circle above it. That means it doesn't really exist there, right? It's just a starting point for the rest of it. This is a function. Yeah, this one would definitely be a function. If that was a solid dot, then yes, you're right, it would not be a function. But that one is, so that one's okay. Let's look at number 8, and then I'm going to give you guys some time to work, kind of fill in some of these gaps, and then we'll get going on the ready, set, go. The table on the right represents a continuous function defined on the interval from 0 to 6. So what they're telling us with it being continuous is that it connects, the points connect, right? So determine the domain and range of x and y. Determine the domain, comma, x and y intercepts. So the domain is going to be x is an element. If it's continuous, can I say 0 to 6? If it's continuous, yes. Yes. And they've already told us that they're including those values. So this is going to be 0 to 6. Oops, bracket, not parenthesis. 0 to 6. What's the y-intercept? Does anybody know? How do we know? 0, 2. I agree. When x is 0, that's your y-intercept. The y-intercept is 0, 2. So this is the y-intercept. Is the x-intercept in here?
Yeah.
Which would be? 2, 0. Right. This is your y-intercept. I'm sorry, your x-intercept. So when you have zeros, that gives you your intercepts. Based on the table, identify the minimum value and where it is located. Which one's going to be the minimum value? That's right. The minimum and the maximum are based on the y values. So this is going to be your minimum. 20 would be the max. That's right. Cool. All right. I'm going to let you guys work with that a little bit.